as I had stated, the fifth module is otherwise a very complex mathematical module which is usually considered by students as something which is to be completed without understanding. But we will try our level best to explain to you what exactly it means. So we are concerned with the network functions. One is the one port functions, those are impedance and admittance, and other is the transfer functions, which is the ratio of voltage upon current or current upon voltage or voltage upon voltage or current upon current, that is admittance, impedance or voltage and current gain or voltage and current transfer ratio. It is what is the terminology for 4? We are having Z21, Y21, G21 and alpha 21. So we maintain the same terminology, otherwise there would be some confusion. Those are voltage transfer ratio, current transfer ratio, transfer admittance and transfer impedance. And then first is the for single port we are having transform impedance and transform admittance, that is Y11 and Z1. Okay, so we are having a two-port network. At one we connect the input, which is a source. At the other we connect the output, which is the load or another network. Similarly, we can cascade it in any order. If we keep the network open, in that case we get the ratios, but two ratios are 0. That is, the I2 would be 0 because no load is connected. So a loaded network and open network. So we have two terminologies. Then the network can contain R, L and C, and also the active network contains dependent sources. As regards to passive network, passive network will always be stable because we will not be in any case getting the concept of negative impedance. Or will be getting the concept of negative impedance. For a passive network, actually the negative thing comes for minus J in that case. Overall negative impedance, I am saying. Is it possible for a passive network to get overall negative? We cannot get, because there will not be a negative resistance. Impedance means if we now decide to plot impedance function. If we decide to plot impedance function, in that case, for a passive network, no impedance function can lie, and if this is, we express impedance as a two-dimensional parameter in terms of S is a complex variable. Then for resistor it is R, and then for inductor it is Ls, for capacitor is 1 upon Cs. R cannot be, R is something which will always lie on positive side. So because of that, this discussion is not complete set of discussion, but just an introduction that for a passive network the question of stability doesn't come, but for active network the question of stability will come, and we will give how it comes into picture. Unstable network means what, and all that we will address the issues by considering an example. So I hope that now you are well aware about the procedure of finding out the functions. We are not going for Laplace transform. We are finding it by considering the concept of impedance, wherein we presume that the signals which we are considering are of the type e raised to st. Signals are of the type e raised to st, and for a signal of the type e raised to st, impedance is R for resistor, Ls for capacitor, and 1 upon Cs for, Ls for inductor and 1 upon Cs for capacitor. So with that, I am sure that you have got enough working knowledge in the sense that if you decide to compute, you can compute. Whether in the class you compute or not, the reason may be you might not have decided to compute. Therefore, you may not compute. But suppose if a contest is held that those who are, if you can compute these functions for 5 circuits, then you will be getting 5,000 rupees. Then you will compute. Means you have got the skill set. Whether you are applying it or not is a different question. But even if 1 lakh rupees is the prize given, you may not be able to explain what does it mean. That we are now discussing. So, we have a 2-port network. We have a 2-port network. It is port 1. It is port 2. Here we connect a source. Here we connect a load. Then V1, I1, I2, V2. If nothing is connected, I2 is 0. If we connect some load, then depending upon what kind of load it is, writing RL is wrong. We have to write ZL. Right? Depending upon what load we have connected, there will be current. Then we deal with the ratio of V1 upon I1, that is Z11, V1 upon I1, that is Z11, and as it is in terms of S, you assume it with Z11S, then V2 upon V1, that is G21S, G21S. I2 upon I1 is alpha 21S. V2 upon I1, that is Z21S, and I2 upon V1 is Y21S. Reverse also we can compute, but those would be, since once we compute Z11, there is no point in computing Y11 because it is 1 upon Z11. Similarly, there is no point in computing V1 upon V2 because it would be simply 1 upon Z21S, right? So this we can completely compute. And inside what can be contained here are L, C and dependent sources. R, L, C and dependent sources. So we take a simple example now. The example what we take is so simple which will give you the concept of stability. Example which we are taking is so simple that it will introduce a concept of stability. So we take the example here. We take most simple network. For this network now, there is no need to specify I1 also because it will say I1 is same. So if it is something different, then we need to specify in the diagram. Otherwise, I1 means everybody knows this is I1. Now compute all 5 parameters. Z11, Z21, Y21, G21, alpha 21. And there you will get some theme. I will not give you much hint, but you will find there is some problem now. Now the task is, some problems will come, and those problems will teach you something. Means you will learn. This is a deliberately introduced example which will make you to learn something. 50 points. In this box we will remove because
सर टू आहे तिथं अरे
so this is I1, this is I2. Right? What is this? Now we start first Z11 we complete. Right? How will you proceed? So have this loop. We have got I1 and I2. So we must get rid of I2, which will give us the ratio, and we will use the other. Okay, is it all right? So we use first loop, and this is for the first loop now. What is the case? V1 is equal to I1 plus I1 plus I2 minus 2I1 or plus 2I1? Minus. Is it all right? Is it okay? So what we have got? V1 is equal to I2. Okay, then go for next loop. For the second loop now, V1 is equal to I1 minus I2 minus 2I2. Is it correct? Is it all right? So V1 is equal to I1 minus 3I2. So we have got two equations. V1 equal to I2 and V1 is equal to I1 minus 3I2. So how to proceed further? We want Z11. Done by how? I2 equal to V1. So V1 is equal to I1 minus we get 4V1 is equal to, is it right? Is it okay? Huh? So we, what point is raised by him is very much appropriate. The thing is that we should isolate this issue from there is likely confusion between the in general two-port network issues which where the parameters Z11, then Z21, Z22 and Z12. I will further clarify it. So as regards to network functions, these are the transform impedance and admittance and the transfer admittance, transfer impedance, voltage transfer ratio and current transfer ratio. So the issue of keeping it open right now is not to be considered. Right now for the given network means here we are not, I would like to clarify, a two-port network which we had like this. There was a systematic way of representing the two-port network by a set of 4 parameters. A set of 4 parameters was required to be expressed and we had option to express either of the set of parameters. What parameters were? Z parameters. In Z parameters, what we were having? Z11. How we were expressing? Voltage was in Z parameters. We were expressing voltage in terms of total parameters of 4. V1, I1, V2, I2. V1, I1, V2, I2. So, any two can be expressed as linear combination of remaining two. So V1 was Z11 I1 plus Z12 I2, right? And V2 was Z21 I1 plus Z22 I2. And we were finding these 4 together by making one of I1 or I2 0. Means we were keeping either port 1 open or port 2 open for that time. Means Z11 we were computing by keeping I2 0. Z21 also we were computing by keeping I2 0. So that is a completely one way of representing the two-port network. Or we can express same by Y parameters. For that we have to short either one of the ports. The same we can express by H parameters. For H parameters, one port you have to short, one port you have to keep open. Or ABCD parameter, again same thing is there. So that set, that Z parameter is not only Z11, Z11, Z12, Z21, Z22 or Y or H or ABCD. That is one form of explaining network completely. Whereas here now we are specifically computing the different network functions. We are more interested in transfer function, and of that one is the impedance function of, that is there are two issues. One is the impedance function is called a driving point function because we take the ratio at the driving point, and others are transfer functions, voltage transfer or current transfer, or transfer impedance or transfer admittance. In this case, we have to compute it for given condition. We have to compute for given condition. So, I compute all, then finish it, finish all. Only if we connect the load, then only the two other parameters, V2 upon V, that is we will be getting G21, no problem. We will be getting Z21, no problem. But alpha 21 and Y21 will be 0 if it is open circuit. So if we consider network only as such, then alpha 21 and G21 will be 0 because I2 will be 0. And when we connect some load, for that loaded condition, we may compute the parameters. We may compute the parameter for no load also. When we compute for no load, that time 2 would be 0, remaining 3 would be getting. So you compute the remaining, and what I was particularly interested in, and for so that you finish first, right? If you are unable to finish, keep it as a homework and now concentrate on this, because once the theme is clear, we should not spend time in which can be done at home in the class. So now for this, in the open circuit condition only, means we are not connected any load. For this network, we are not connected any load. For this now, you compute Z1, and there I find an interesting situation will be created. An interesting situation will be created when we try to compute Z11 for this. Obviously, this I1, V1, V2, I2 will be obviously 0. And here something should click in your mind, and there you will start the theme of stability and all these things. So I think we shall solve collectively. We will not spend time in asking you to solve. So we need to only have one loop. We need to have only one loop that will give you all the values. That is V2, we can get it because this voltage, V1, I1. So V1 upon I1 is Z11, V2 upon I1 is Z21, and V2 upon V1 is G21. All issues we can get. We just go for first simple. V1 is equal to I1 plus what this would be? Again I1, right? Because I2 is 0, so I1 and what? Minus KI1, right? I hope how minus you have got everything. If voltage source is in this direction, then it goes minus. Okay? So what we will be getting here? V1 is equal to 2 minus K I1. V1 is 2 minus K I1. V1 is 2 minus K I1. Okay? So Z11 is equal to 2 minus K. Z11 is 2 minus K. And now we brainstorm on this issue rigorously. Even though we are in the age of information explosion, there are some issues on which classroom discussion is still relevant. and this is one of them. So Z11 is equal to 2 minus K. Z11 is equal to 2 minus K. What does it mean now? And what does it mean?
Changes according
What
to K.
will be the case if K is equal to 2? What will happen?
Z1 is 0.
If K is 2, it is short. Okay, that also we may agree that I can short. But what if K is equal to 3? If K is 3, how the thing will take place? If K is 3, compute. If K is 3, and what if K is 2? It will demand infinite current. If K is 2, I1 would be infinite. I1 would be infinite. What will be V2 then? What will be V2? If, okay, let us say that K is equal to 2. Let us discuss K is equal to 2. Then what will happen? If K is 2, Z11 becomes infinity. 0. Sorry, Z11 becomes 0. Z21 or G21, G21, G21 infinite. G21 becomes infinite. Is it correct? Why Z21 should become 0? Okay. G21 becomes, right? G21 is what? How will you compute G21? V2 upon
V1.
V1. So what is V2?
1 minus K.
We can write the equation. If now, or you can compute, so Z11 is 2 minus K. You can compute independently G21. How you can compute G21?
V2 upon V1.
V1 is equal to 2I1 minus KI1. What is V2? V2 is equal to V2. What is V2? This voltage. What is V2? I1 minus KI1. This voltage plus this voltage in a proper sense. So V2 or V2 is equal to V1 minus I1. V2 is V1 minus I1, right? It's so simple. V1 minus I1. V2 is V1 minus I1. Is it right? So what is V2 upon V1? So I1 will be expressed in terms of V1. So V1 is equal to 2 minus K, right? 2 minus K I1. So I1 is equal to
1 minus K.
V2 is equal to V1 plus I1 is equal to V1 upon or 1 upon 2 minus K V1. Is it right? Minus or K minus 2, correct? So V means V2 is equal to V2 equal to V1 into bracket 1 plus K minus 2, 1 upon K minus 2. That is equal to V1 into bracket And Z21, for Z21 what you are going to do? You want V2 in terms of I1. You want V2 in terms of I1. So in place of V1 you should put this. So V2 that will come to V2 equal to again 2 minus KI1 minus I1, that is equal to 1 minus KI1. So V2 Z21 is equal to 1 minus this thing we have completed. And now what we mean by unstable network. What we mean by unstable network. What is stability? If K is equal to means actually such unstable net, whether really infinite voltage can be generated or not is a different issue, right? So to that we shall come later. If K is put as 2, if as I had already stated, if the circuit does not contain active sources or if the circuit does not contain dependent sources, then it is a passive network. If circuit doesn't contain dependent sources, then it's a passive network, and the question of stability of passive network never comes. Question of stability of passive network never comes. But as regards to active networks now, if K is equal to 2, then G21 becomes infinite. G21 becomes 2 minus 1 upon 0, infinite. Means non-infinite or finite V1 leads to infinite V2. Bounded input is leading to unbounded output. Bounded input is leading to unbounded output that corresponds to an unstable network. The network is not stable. Network is not stable. So the concept is network is not stable. If K is equal to 2, we are getting unbounded output. Right? Means even if the actuators are finite, voltage or current somewhere becomes infinite, that means the network is unstable. In practice, this cannot arise because the dependent sources which we connect are themselves prepared by using transistorized circuits or op-amp circuits, for which they are limited by their power supply. Means the dependent sources fail to act as dependent sources. Means the dependent source itself is some circuit. It acts as a dependent source. Means the dependent source circuit prepared is generating KI1, provided that the voltage generated by the dependent source is below some level. Up to that level, it can generate KI1. But the dependent source itself is an amplifier. And it can generate some voltage subject to limit of some maximum voltage. Therefore, in practice, getting infinite voltage and then getting shocked and everything, such thing doesn't happen. So, dependent source itself is a constrained or limited dependent source. Means it. So here most important part in this is KI1. This is a voltage source. Which generates voltage proportional to this current. And the system is like this. When this increases, what is going to happen? It further increases. It is regenerative, which will give rise to further increase. k is equal to 1, what will happen? If k is equal to 1, if k is equal to 1, what happens? If k is 1, in that case you can give some voltage, some stable current. Let us take that case. If k is equal to, we have 3-4 cases and try to consider what happens. If k is V1, we give 1 volt and I will be compute. V1 we give 1 volt and I will be compute. What is V2? V2 is V1 minus I1. So we can also write that. If k is 0, what will happen? Moment at which k is 0, it becomes a passive network. Moment at which k is 0, it becomes passive network. It has to be stable. So straight away I1 is equal to V1 by 2. 1 and 1, right? So I1 becomes half, I1 becomes 0.5, V2 becomes 0.5. If k is 1, what will happen? V1 is 1 volt. This is 1 volt. I think volt I will not write. Units are presumed units. If k is 1, what will happen? So how can I write the equation? 1 is equal to I1 plus I1 minus I1. Right? So I1 is 1, V2 is 0. Right? K is 3. What will happen? What is I1?
-1.
It is -1. Negative resistance means we have connected voltage and because of negative resistance, current will flow in the source. So minus I, -1. And what is the voltage?
2.
2 volts. And if this 2 means 1, what will happen now? I will be infinite. Right? So this part leads to instability. This part leads to instability. In finite exciting source leads to infinite parameters. A finite exciting source leading to infinite parameters. We will take the last interesting example and then we shall wind up. Compute G21. It's open circuit. We are not connected any load as such. Compute G21. Pause. It again comes in terms of K. And again depending upon the value of K, whether it is to be stable or unstable network, it is decided. So we will be just having prepared this for tomorrow. For the transfer function, which we get as a function of some polynomial in the numerator upon some polynomial in the denominator. The polynomial in the denominator is of much interest, and based on that we get some criteria about the stability. So henceforth, ultimately all these things are the functions in terms of S. If it is completely resistive, then there will not be any term of S. If it is a completely resistive network, then the question of S will not be there. But we consider in general a network consisting of R, L and C. So all network functions may it be driving point function, that is impedance at the input port itself, or transfer function, may it be transfer ratios or transfer impedance or transfer admittance. All these functions, network functions, are ratio of one polynomial in the numerator upon another polynomial in the denominator. Both are polynomials in S. Especially the denominator polynomial is meaningful for the stability of network. And we can in general look at the properties of these polynomials. It's a somewhat classical discussion, but we will go for each property. We will try to do the property by the concept of negation. Means we shall disprove the property first. We shall violate the property and try to design something for that, and we will come to know that we can't design that, means that the property is validated. So ultimately, for a voltage or a current source which is of the type of e raised to minus e raised to st, we can compute all these parameters. These describe different network functions which are ratios of at the same port for driving point or the cross ratio, other port to this port. We will continue tomorrow at usual time, and then for Monday on.